Good morning. My name is Joyce Shen and welcome to Risk Management Professionals webinar series. Today I will be providing an overview of RMP, PSM, and CalARP program development. This webinar series is part of RMP's ongoing outreach program. RMP's core competencies and expertise resides in EPA RMP, OSHA PSM, CalARP, and SEMS program development. This also includes HAZOP and LOPA studies and other hazard identification techniques, and a variety of other process safety and regulatory standards, which you can find listed here or on our website. Before we begin, here is an outline of what we will be covering today in our webinar. The goal of this webinar is to provide an overview of the various federal and state programs of which regulatory documentations are required. Most importantly, after this webinar, we should be able to determine what regulatory requirements a facility should comply with and what extent of documentation would be required of that said facility. In addition, we will also discuss a few common questions regarding these programs. Let us start with our overview. So what is RMP? RMP stands for Risk Management Plan, and it is a part of the regulation published by the EPA, or Environmental Protection Agency, in order to comply with the Clean Air Act amendments. This regulation applies to facilities that contains an amount of regulated substance that exceeds a certain threshold. You can find more information for the substance list for RMP as well as other regulatory programs through the hyperlinks found on the handout that I will attach to this presentation. Under the RMP rule, facilities that uses these hazardous substances are required to develop a risk management plan, which would first identify the potential effects of a chemical accident, 2. Identify steps the facility is taking to prevent an accident, and 3. To spell out emergency response procedures should an accident occur. A facility will be assigned or categorized to a specific program level based on the amount of regulated substance within their cover process. Most of the time, a facility is either categorized as Program 2 or 3. A facility will only be considered Program 1 if it satisfies the following criteria. 1. Processes have no public receptors within the distance to the endpoint from a worst-case release. And 2. Facility has no accidents with specific off-site consequences within the past 5 years. Only then would the facility be eligible for Program 1, which would impose minimal requirements on the process. We will discuss the details of each program requirements in the later slides. Before that, let us finish our overview for RMP. To fulfill the 3 main objectives, the risk management plan includes, but are not limited to, the following elements: safety information, hazard review, operating procedures, training requirements, maintenance requirements, compliance audits, and incident investigation procedures. We will dive deeper into the various elements in just a little bit. But before that, let's discuss PSM. PSM stands for Process Safety Management, and the program falls under OSHA, or Occupational Safety and Health Administration. Under the Clean Air Act amendments of 1990, OSHA developed standards for the process safety management, which covers facilities that manufacture a list of explosives and other harmful materials. PSM does not apply to the following facilities, which includes retail facilities, oil or gas well drilling, or remote servicing operations that are normally unoccupied, and facilities where highly hazardous chemicals maintained on site fall below OSHA's threshold quantity. PSM has 3 simple objectives, which is to identify risk, evaluate risk, and control risk, which are to be fulfilled by a whopping total of 14 elements within the PSM program. For PSM, these are the required process safety elements. A lot of these elements, as you may have observed, overlaps with the RMP. Therefore, it is very important to know where your facility falls in terms of compliance and work to develop the necessary elements to fulfill regulatory requirements. Aside from the EPA RMP and OSHA PSM, there is one that is essentially RMP for California, one that is specific for California, which is known as CalARP. In California, RMP is replaced with CalARP, which are very similar and will essentially require most of the items found in RMP, but with minute differences. The main objectives of the CalARP is to 1. Prevent accidental releases of harmful substances. 2. Minimize damage from the accident. And 3. To satisfy community right to know laws. Note at the asterisk that due to the 2012 fire and chemical release from the Chevron Richmond Oil Refinery, a CalARP Program Level 4 is developed to address deficiencies and gaps of Program Level 3 for the refineries. For more details on CalARP Program Level 4, please refer to our previous webinars. Now, what are the minute differences between EPA, RMP, and CalARP? While both would essentially require the same documentations, there are still a number of variations between the two programs. For example, the list of chemicals for CalARP is larger. Specifically, we're looking at 276 substances under CalARP versus 77 substances under RMP. In addition, the threshold quantity, or TQ, of the chemicals for CalARP is smaller. For example, chlorine TQ for CalARP quantity is 100 pounds, while for RMP is 2,500 pounds. CalARP also requires an external events analysis to be performed, and this includes seismic analysis. Lastly, CalARP not only requires a risk management plan, but overall also requires more interaction with the public as well as associated agencies. This is by all means not an exhaustive list of all the differences, but these are examples of what has changed in CalARP compared to the regular federal RMP. So now that we have gotten a better idea of each program and what it seeks to accomplish, let us discuss the program levels and how to determine where one's facility would be categorized. The differences in program levels means differences in the requirements needed to be fulfilled. Some of the critical factors which determine a facility's program level includes proximity to public receptors upon a worst-case scenario, which is determined through dispersion modeling, occurrence of off-site impacts with a regulated substance, which is whether there have been accidental releases previously, and whether the process is subject to OSHA PSM standards and the NAICS codes, which is determined by substances used in the process. If you follow through this helpful flowchart and answer the following questions, you can help yourself determine whether you are eligible for Program Level 1 or that you are subject to either Program Level 2 or Program Level 3. Here is another roadmap that could help us see and understand the differences between these program levels a little better. Essentially, there is little to no requirements for Program 1, though most, if not all the time, most facilities are unable to be categorized as a Program Level 1 facility due to the potential for worst-case scenario impacts. Program 2 and 3 share very similar requirements with a few specific elements that are specific to Program Level 3, while Program Level 2 may be less stringent or demanding on what information must be included. This is a very helpful table that clarifies every specific element each program requires. As one may observe, Program 3 requirements include a few additional items such as management of change, pre-startup review, contractors, employee participation, and hot work permits. As a process safety consulting firm, we have provided program development services for many facilities belonging to any of these programs, especially for Program 2 and Program 3 facilities. This table shows some of the prevention program overlaps between the various programs. Note that this list is true for RMP and CalARP Program Level 3 facilities. One important thing to realize is that if PSM standards does apply to your facility, you are automatically considered an RMP CalARP Program Level 3, so that is something to be aware of. Now, perhaps there is a facility which holds regulated substances on site, but none are over the threshold quantity, or perhaps the facility deals with chemicals not listed on the regulated list. Does that mean the facility does not need to be considered for potential hazards? The answer is no, because we have what is known as the general duty clause. Sometimes the regulated substance list is simply unable to catch every kind of chemicals that are being used within facilities. Nevertheless, it doesn't necessarily mean that the chemicals not included in the list will not lead to any safety or environmental concerns. For that reason, there is the general duty clause, which requires facilities with these kinds of chemicals to complete the following items. 1. Identify all chemical and process hazards associated with extremely hazardous substances. 2. To design and maintain a safe facility with necessary steps to prevent release. 3. To minimize the effects of accidental releases. How is a facility able to fulfill these requirements? Through having process hazard analysis or hazard review, through documenting process design, maintenance, operations, and training, through documenting or developing an emergency response plan. Before we move on, I'd like to provide notes on what it would take for the OSHA to issue a general duty clause citation. 1. There must be a hazard. This is per judgment of the OSHA compliance officer upon inspection. These officers are usually looking for injuries related to a hazard and standards addressing this apparent hazard. Therefore, if you are noticing some common injuries occurring on your site, please make sure to have standards that addresses these hazards. 2. The hazard must be recognized. There are a few ways in which a hazard is considered recognized. One is that injury records and documentation, such as OSHA 200 logs, workers' compensation records, accident investigation reports, insurance company reports, medical records, etc., are found on site and can prove that a hazard does indeed exist. Or that employer have previously initiated actions related to this hazard, such as having programs, precautions, directives, and etc. Or you have related unions that file grievances with management and or may have made effort to rectify hazards and safety issues, or that they have discussed safety inadequacies in meetings. And lastly, you have standard hazards that are backed by incidents, fact sheets, and or acknowledgments by safety experts within the industry. All of these following can make a hazard recognized, and it is best to be aware of these potential hazards. 3. The hazard causes or is likely to cause serious health or death. The serious health issue is anyone that leads to impairment of the body, which affects life functioning and or significantly impair working efficiency. Lastly, this hazard must be correctable. And by correctable, it means it has feasible and known ways to correct this hazard, such as through physical means, admin controls, safety training, etc. Now, the key here is hazards. It is important to note that accidents or incidents doesn't necessarily lead to a general duty clause violation. It is also important to note that the general duty clause is not a regulation and compliance cannot be checked against a regulation or submission of data. Therefore, the best practice here is really to be conservative and make sure all hazards are properly addressed and that all required documentations are developed that can help address these hazards. With that being said, we can finally dive right into the various program documentation elements. In the upcoming slides, there is a little table on the upper right-hand corner, which you will see in a little bit, which shows which program requires the element that is being discussed. PSM is PSM, GDC is General Duty Clause, and the P1, 2, 3 are program levels 1, 2, and 3 for RMP and CalARP. First off, we have the hazard assessment, which looks at the potential for a regulated chemical to travel offsite from a release and affecting various receptors and populations. Some receptors include residential areas, recreational areas, schools, and etc. A hazard assessment shows the cover process, which include any chemicals within that process that are above the threshold quantity. It also shows worst-case release scenario, which are usually modeled using the total release from a vessel with the largest quantity or capacity of the regulated substance. These could be tanks, pipings, and many others. Worst-case release scenarios are usually very unlikely scenarios that would occur, and while it may look very severe, it should not and will not affect an auditor's perspective of the site. If anything, it would be best to be conservative with the worst-case release scenario, as that would prevent the inspectors from finding any other cases that could have a wider release and put you into trouble. Lastly, there are alternative release scenarios, which are less severe but more likely to occur than worst-case release scenario, and these are ones where you see potential that it would occur on site. Next off is 5-year accident history. This is where you document any accidental releases from the cover process in the past 5 years. Accidental releases are one that leads to deaths, injuries, significant property damage on site, or any known off-site deaths, injuries, evacuations, sheltering in place, property, or environmental damage. These events are usually considered incidents and would also be addressed within the incident investigation. Note that this pertains to releases of chemicals under the proper process and not every kind of accidents on site. One example of an accident that would not be included in the 5-year accident history is if an operator falls from a tank while climbing a ladder. Because it is not related to a release of chemical, it would therefore not be included as part of the 5-year accident history. The following elements that we will be discussing in just a little bit are ones that are specifically found in a preventative program under the program development. Let's get into it. First off is process safety information, or PSI. Within the PSI, you should find 3 things. 1. Hazards of regulated substance in the process. 2. Technology of process. And 3. Process equipment. Under the chemical hazards, you should address the toxicity, permissible exposure limits, physical data, reactivity, corrosivity, thermal and chemical stability, and hazardous effects of network mixing of materials. Under process technology, you should include block flow diagram or simplified process flow diagram, process chemistry, maximum intended inventory, safe upper or lower limits for items such as temperature, pressure, flows, or composition, and evaluation of the consequence of deviation. Lastly, for process equipment, you should include materials of construction for the equipment, your piping and instrumental diagrams, or PNIDs, electrical classification, relief system design and design basis, ventilation system design, design codes and standards employed, your safety systems, and lastly, material and energy balances, specifically for processes built after June 21st, 1999. Note that under Program Level 2, it is called Safety Information, but essentially you should include all of these following items in your SI, just like what you would do in your PSI for Program 3. Next off, we have the Process Hazard Analysis, or PHA, and it is notably one of the key services that we provide as a process safety consulting firm. The goal of the PHA is to identify, evaluate, and control hazards, and you can do so by choosing one or more of these methodologies, which include what if, checklist, a combination of what if, checklist, hazard and operability analysis, which is HAZOP, failure mode and effects analysis, which is FMEA, fault tree analysis, and any appropriate equivalent methodology that the site decides to use. These analyses should address process hazards, previous incidents, engineering and admin controls, consequences of failure of these engineering and admin controls, stationary source siting, human factors, qualitative evaluation of a range of possible safety and health effects of failure of controls, and lastly, consideration of external events such as seismic events if applicable. This, a reminder, is applicable for CalARP. A process hazard analysis shall be performed by a team with expertise in engineering and process operations, at least an employee with experience and knowledge specific to the evaluated process. Usually we're looking for a unit operator and a unit tech engineer, and one member that is knowledgeable in a specific PHA methodology being used. Usually this is the facilitator of the PHA. Any action items and recommendations made during the PHA must be resolved and documented in a timely manner. This is usually done by having a written schedule, a timetable for completion, and the timetable or the time frame should either be agreed upon by AA or within 2.5 years of PHA completion or next planned turnaround. You should make sure that the final resolution and actual completion dates are documented and that any related personnel are informed and communicated of the changes made. An important thing to note is that PHAs should be updated and revalidated every 5 years, even if no changes were made to the process. Next off is operating procedures, which requires you to develop and implement written operating procedures to provide clear instructions for safely conducting activities involved in each cover process. They should be consistent with the PSI. Also includes steps for each operating phases listed here. It should also include operating limits and address consequences of deviation and steps required to correct and avoid these deviations. It also includes safety and health considerations such as properties and hazards presented by chemicals in process, precautions to prevent these exposures such as through engineering and navigation controls, PPE, and etc., control measures for physical contact and airborne exposure, quality control for raw material and control of hazardous chemical inventory level, and lastly, special unique hazards. It should also include safety systems and their functions. Operating procedures shall be readily accessible to employees who work in or maintain a process, and shall be reviewed as often as necessary to make sure that it reflects all changes to operating practices, process chemical technologies and equipment, and stationary sources, etc. It should also be certified by owner-operator for accuracy and accuracy on an annually basis. Note that if you are submitting an RMP via EPA CDX, it will show warning if the operating procedure last review date is more than a year away from the data submission. You also need procedures for both in-unit operators and in-unit outsiders that are non-operational. This applies to maintenance, engineering, and management personnel, and even visitors that comes on site. Some potential issues inspectors would pick on includes having a revision date that is more than a year from data inspection, realizing that operators is saying things that are different from what is written in the SOPs, and that management of change documents and the listed changes were not reflected in the SOPs. So these are things to be aware of. Next off is training. It is essential to ensure that each employee operating a process, whether it is present or new, has been trained and tested competent in operating procedures pertaining to their duties, such as through written test, oral test, observations, or any other methods that can prove their competency. Also, it is important to provide refresher trainings to at least once every 3 years and more if deemed necessary to ensure employee understanding of the operating procedures. If you are unsure of what kind of training is adequate for your process, you may use training conducted either under federal and state regulations, industry-specific standards, or equipment vendors' standard codes. Lastly, ensure operators are trained in any new and updated procedures prior to startup after major changes. Some of the common deficiencies found in training is that not all employees have received refresher training, which includes process maintenance and contractor personnel and those who work multiple shifts, particularly for those that work overnight and weekend shifts. Also, not making sure that all documentations of each person's trainings are kept and filed, and that it shows how understanding your training was verified. This could simply be a copy of the test they took. And lastly, having an operating procedure training that is not facility specific. Always make sure that your operating procedure training is facility specific. This table shows some of the requirements for training. This includes operating procedures, safe work practices, and refresher. This applies to both Program 2 and 3. Maintenance applies to Program 2, and mechanical integrity applies to Program 3. Management of change and pre-startup applies to Program 3 only, and contractors and emergency response are both applicable for Program 2 and 3. Next off, we have mechanical integrity and maintenance. Please bear with me as the slides may look kind of chunky. But first off, you will need a written procedure, which should include a method to allow employee to identify and report potentially faulty and unsafe equipment and to record their observations and suggestions in writing. Employers should address them in a timely manner. Some resources for written procedures may include vendors, equipment manufacturers, trade association, industry standards and guidance, ones that are developed in-house and from your maintenance history. Secondly, you must include training for process maintenance activities. Thirdly, you must include inspection and testing for your equipment. These should follow recognized and generally accepted good engineering practices or REG-GAP. Your inspection frequency should be consistent with applicable manufacturer regs, good engineering practices, and previous operating experiences. Lastly, your inspection should be documented with name of inspector, date, equipment identifiers such as through serial number, description of inspection, and the results from the inspection. You should also address equipment deficiencies that are outside acceptable limits as stated in your PSI. And you should demonstrate quality assurance, which shows that new equipment is suitably fabricated for associated process applications. It should show that checks have been performed and inspections have been performed to assure proper installation and consistency with design specs and manufacturer's instructions. And it should show that maintenance parts and spare parts and equipment are suitable for associated process applications. Some of the common deficiencies you may find in mechanical integrity and maintenance is that there are no written mechanical integrity procedures, even though your maintenance procedures are in place. So make sure they are properly written and documented. Another one is that equipment is not inspected or tested. Another is that testing inspection interval doesn't meet industry standards. And that it fails to follow record gap, which includes proactively replacing relief valves, proactively replacing hoses, and painting. Another one is that you have no plan for replacing equipment when it fails, no program for monitoring integrity of tanks, notably the worst case vessel that we're talking about, and failure to consider piping, particularly underground piping failures and maintenance for the piping. Next off, we have the compliance audit. It is important to certify evaluation of compliance at least once every 3 years to verify adequacy of procedures and practices. Note that it is a requirement to retain 2 most recent compliance audit reports. Nevertheless, any other reports that is more than 5 years old is not required to be kept. Compliance audit should be conducted by at least one person who is knowledgeable of the process, and after compliance audit should develop a report to document these findings. Make sure you determine appropriate response for each action items or recommendations and resolve them in a timely manner, which is no more than 1.5 years after compliance audit were completed. One major red flag an inspector may pick on is if they find same findings appearing on subsequent audits. Therefore, it is important that we complete our compliance audit to the best of our ability and documenting in detail of any possible inadequacies and having action items to address those inadequacies. Some common deficiencies found for compliance audit is if you're not conducting compliance audit on every process every 3 years. Note that upon submittal into the EPA CDX, any dates of most recent compliance audit that are more than 3 years from date of submission will come out as an error, and you will not be able to submit the RMP as the system will not accept any errors. Another is if you have no certification by a company official. This is needed for the compliance audit in order to make it valid. Another is failure to detect major prevention program errors. A compliance audit was performed, but if done poorly, will lose its purpose as a pre-check prior to the auditors. Compliance audit is supposed to be like a regular body checkup for the cover process to ensure that all aspects of the process is well maintained and agreeing with regulatory requirements. Another is if issues were found that were not addressed and documented. Similarly, an inspector finds an obvious issue that was not addressed in a compliance audit shows that the compliance audit was not carefully conducted. One of compliance audit's most important goal is to find issues in the process ourselves before the auditors or inspector does. Another is if action items were not documented or tracked to ensure resolution. During compliance audit, issues were found, but no actions were taken, and no timetable was implemented to take care of the hanging action items. Therefore, it is important that you keep track of your action items and make sure they're done in a timely manner. Lastly, is only partially audited or assumes that actions audited previously do not need to be evaluated. It is oftentimes easy to miss certain not so obvious dates, such as yearly review of operating procedures, so it is best practice to make sure all sections are thoroughly audited and that audits are not done partially. Next off, we have incident investigation. Please also bear with me on this one, as it is a little chunky, but should be a little better. Let us start off with some definitions. So, incident refers to events that resulted in or could reasonably result in a catastrophic release. And a catastrophic release refers to one that presents imminent and substantial endangerment to public health and the environment. Some examples of reportable incidents include anything that are included within CER CLA, EPCRA, RMP, OSHA 300 log, MOC triggered incidents, and very importantly, near misses. One major red flag an inspector may find is if the only finding in the incident investigation was equipment failure and/or human error at fault. Therefore, it is very important that we are thorough with our incident investigation to make sure we cover everything before the inspectors does. Alright, so some of the key items for incident investigation includes finding the root cause of the incident, learning from the experience of the incident, avoid repeating those mistakes, and having or setting procedures, programs to prevent recurrence and future injuries. For these investigations, some of the requirements is that you must investigate each incident no later than 48 hours after the incident occurring. This includes weekends, with a team including one person knowledgeable in process, contractors if applicable, and one person knowledgeable or experienced with the said incident. The incident investigation report must include start date of investigation, incident description, and recommendations, which is to be completed no later than 1.5 years after investigation completion or 2 years after date of incident, whichever is closer. The incident investigation should be reviewed with all affected personnel, and the report must be retained for 5 years. The upcoming elements are ones that pertain specifically to Program 3. First off, let's discuss management of change. So our facility is going through changes. What do? We need to make sure we establish and implement written procedures to manage changes to process chemicals, technology, equipment, and procedures, as well as changes to stationary sources that affects the cover process. These procedures must ensure considerations are addressed, and these include technical basis for proposed change, to describe change and provide drawings and specs, impact of change on safety and health, modifications to and/or developing of new operating and maintenance procedures, the needed time period for change, whether this is a permanent change or a temporary change with an end date. And lastly, authorization requirements for the proposed change, whether the level of authorization is appropriate and whether it's done before the change. Prior to startup, ensure associated personnel are informed and trained for the change. And lastly, to update PSI, OP, MI, PHA, and any other sections within the program as needed if it is affected by those changes. Some of the common deficiencies found in the MOCs is the failure to follow replacement in kind. Note that a change in original equipment manufacturer specs is a change. Also, MOC processes were not completed prior to change. MOC should not be an after-the-fact paperwork, but it should be done before the change were already made and implemented. And lastly, not having updated the process safety information, your SOPs, and etc. Note that if the MOC is not completed, it will delay the PHA process. It is very important that all documentations have been updated to reflect all the MOCs prior to your PHA study, as any changes made after the PHA would devalidate the study results from your PHA. Next off is pre-startup safety review. You should perform a pre-startup safety review for new and/or modified stationary sources when the modification is significant enough to require the change in your process safety information. You should confirm through verification and checked, that is independent of MOC process, that prior to introduction of regulated substances to a process, that construction and equipment is in accordance with design specs, that safety, operating, maintenance, and emergency procedures are adequate and in place. For new stationary sources, a PHA has been performed and recs resolved before startup, and modified stationary sources meet the requirements contained in the MOC, and training of each employee involved in operating the process has already been done. These confirmations must occur prior to introduction of regulated substance to a new and/or modified process. Failure to do so could and does cause accidents. Some of the common deficiencies of a pre-startup safety review include not conducting the pre-startup safety review prior to the start of the process, like we already mentioned. Construction and equipment is not per design, and that PSI was not updated accordingly. So make sure definitely make sure that your pre-startup safety review is properly conducted. Next off is employee participation. Make sure to develop written plan or action to implement employee participation. You should consult with employees and their representatives on conduct and development of PHA and on development of other elements of process safety management, and make sure to keep them in the loop. Lastly, provide employees and their representatives with access to PHAs and all other required information, such as the process safety information, operating procedures, mechanical integrity, incident investigation, management of change, pre-startup safety review, and emergency planning and response. Some of the common deficiencies found in employee participation includes not having a written employee participation program. Though it may be implemented on site, if you don't have a written documentation for it, you can still get in trouble. Another is that employees were not involved in the development of PHAs and other elements. It is very important that one keep this idea in mind that the PHAs and all the other elements developed for the prevention program, and their essential goal is to keep the employees aware of potential hazards and what they can do to protect themselves from the hazard. So it's important that they're either involved or they're well aware of where they can access this information. Lastly, another deficiency is that written employee participation program is there but is not followed. This can happen, or they can find this when inspectors come on site and find personnel who are not aware of these various programs or do not know who, where, and how to access these documents. So definitely keep those in mind as you develop your employee participation. Next off is hot work permit. Now, what is hot work? These are works involving electric or gas welding, cutting, brazing, or similar flame spark producing operations. For the hot work permit, it is important to ensure to issue a hot work permit for any hot work operations conducted on or near a covered process, if that is applicable for you. These permits need to document that prior to starting any hot work operations, requirements for fire prevention and protection have been implemented. These fire preventions could be anything such as covering or moving items or equipment nearby that can easily catch fire or become damaged in presence of fire, or having items such as fire extinguishers that can mitigate fire damage. On your permit, also make sure the date of authorization for hot work is listed, and make sure the permit identifies object that the hot work is performed on. Make sure you keep permit on file throughout the associated hot work operations. Nevertheless, once you're done with the hot work operations, the permit is not required to be kept. Now, some common deficiencies for hot work permit includes not having a fully completed permit and not maintaining it according to proper procedures. Next off, we have contractors. This applies to contractors performing any of the following tasks: maintenance and repair, turnaround, major renovations, and specialty work on or adjacent to covered process. The following are responsibilities for the owner or operator, which is to obtain valuable information regarding contractor's safety performance and programs, to inform contractor of known potential fire, explosion, or toxic release hazards related to their work or process, to explain to contractor applicable provisions of emergency response program, to develop and implement safety work practices consistent with section operating procedures to control entrance, presence, and exit of contractor in covered process area, and to periodically evaluate and document performance of contractor in fulfilling these obligations. Note that contractors are responsible in relaying the above information to their employees who are performing tasks within the area of covered process. The elements after this section is not within the preventative program. Last but not least, we have the emergency planning and response. Note that this applies to every program levels, as well as the general duty class and the PSM, because it is very important that we are sure of what procedures to take in case of an emergency. Now, we are separating. There's a difference between non-responding facilities and the responding facilities. Let's first cover the non-responding facilities. These non-responding facilities are not required to develop an emergency response capabilities. These, for example, could be retailers and other small operations with few employees. OSHA and EPA does not expect these facilities with only a few people on site to be able to handle a major release all on their own. So an emergency response plan is not necessary. Nevertheless, they still need to develop an emergency action plan, which is EAP, to ensure employee safety. And these includes emergency action guide, such as through a flowchart of what to do, course of actions, a general location information, vicinity map, emergency evacuation routes, associated trainings, emergency contact list that includes employees, agencies, etc., an evacuation plan, and any other plans such as earthquake, bomb threat, injury, first aid, spill, and/or release plans. These facilities still need to ensure effective emergency response, which could be done through the following: supplementing on-site response with response contractors or via mutual aid agreements with other nearby sources, working with local emergency response officials to identify gaps in local responder capabilities and assisting in supplementation as needed, and implementing purely defensive response measures, such as through evacuations. And for responding facilities, they are required to develop an emergency response program, which includes procedures for informing the public and appropriate federal, state, and local emergency response agencies about the releases, documentations of proper first aid and emergency medical treatment that is necessary to treat human exposures, and measures for emergency response. In addition to the emergency response plan, they should also have procedures for using, inspecting, testing, and maintaining emergency response equipment, having training for all employees in the relevant procedures, and to review and update the ERP to reflect changes at the facility and ensure employees are informed of the changes. Plans should be updated accordingly based on facility changes, new information from coordination activities, emergency response exercises, incident investigations, and etc. And in addition to the emergency response plan and all of the following previously mentioned items, they also need to develop an emergency action plan just like the non-responding facilities in the same way and to follow all OSHA EPA HAZWOPER standards. As you can see from the ERP, employee training, medical monitoring of employees, record keeping, etc. Trade secrets. This one is specific only to the OSHA PSM, and it requires that all information necessary to comply with the section available to those persons responsible compiling assisting in the following: process safety information, process hazard analysis, operating procedures, incident investigation, emergency planning and response, and compliance audits without regard to possible trade secret status of such information. In simpler terms, all of the information that are related or pertains to the following documents should not be restricted from any personnel that are responsible in assisting or complying these documents. Nevertheless, employers do have the rights to request that these associated persons enter into confidentiality agreements and to make sure that the informations are not disclosed. Still, employees have rights to access trade secret information which pertains to the documentations we have listed. All right, thank you for your patience. We will now dive into some common Q&As. When determining whether a threshold amount of a regulated substance is present in a process, such as in a tank, must the owner or operator of a stationary source consider the total capacity of the process or the actual amount of regulated substance contained in the process? The answer is threshold determination is based on the maximum actual amount of the regulated substance contained in the process at any one time. The key here is regulated substance. The owner or operator must implement documented administrative controls to limit the quantities in the process to ensure threshold quantities are not exceeded. According to the definition of process, in Title 19, Section 2735.3, any group of vessels that are interconnected is considered to be a single process. If a stationary source has two interconnected vessels and one contains 6,000 pounds of butane while the other contains 6,000 pounds of propane, is this a covered process under the CalARP program? The answer is no. For this to be subject to RMP regulations, it must contain more than the threshold quantity of a regulated substance. The threshold quantity for both butane and propane is at 10,000 pounds. if at any time more than 10,000 pounds of either butane or propane, when not used or sold as fuel, is present in a process, that process is covered by the CalARP program regulations. Note that even though it is not subject to RMP regulations, it is still subject to the Federal Clean Air Act and therefore the General Duty Clause. If butane and propane are present as mixture in the process, then the threshold quantity of the propane and butane mixture should be used instead as the determining factor. Next. What if the quantity in the process fluctuates? I may not have a threshold quantity now, but I will intermittently exceed the threshold quantity. Now, you do not need to comply with the rule and file an RMP unless you have more than the threshold quantity in the process. However, once you have more than the threshold quantity in the process, you must be in compliance immediately. In this situation with fluctuating quantities, it may just be prudent to file now so you will be in compliance when your quantity exceeds the threshold. You may also want to consider a proactive filing. And in this case, predictive filing can be very helpful as it means you will not be required to update and resubmit your RMP every time you receive a new regulated substance, if that substance was included in the latest RMP submission, and so long as the quantity does not change to the point where offsite consequence analysis would need revision. However, if you intermittently exceed threshold quantity and you do not file an RMP, if at any time an inspector visits the site and finds that the threshold quantity has been exceeded and you do not have an RMP, you immediately get in trouble. Therefore, the suggestion or the best practice is to still file an RMP if you have potential to intermittently exceed threshold quantity. Pursuant to the Risk Management Program regulations, the owner or operator shall identify and analyze at least one alternative release scenario for each regulated toxic substance held in a Program 2 or 3 process above its threshold. If a facility has both ammonia and ammonia, that is anhydrous, on site above their respective threshold, does the facility owner or operator need to complete an alternative release scenario for both ammonia and anhydrous ammonia, or can they complete just one? Ammonia with concentration that is 20% or greater and anhydrous ammonia are listed separately under Section 68.130, Table 1, under different CAS numbers and different threshold quantities. Ammonia that is at 20% concentration or greater and anhydrous ammonia should each be treated as individual toxic substances, and as such, each will require their own alternative release scenario if in a Program 2 or Program 3 process. Nevertheless, if the same process, such as anhydrous ammonia, is above the threshold in several processes or locations, you need only analyze one alternative release scenario for it. Thus, the key here is because the liquid ammonia and the anhydrous ammonia are listed separately, and for that reason, they are considered individual toxic substances and should require their own alternative release scenario. Finally, to summarize, our suggestion is that when in doubt, it is better to be conservative than to stay by the border of noncompliance. And you can do so through the following. Follow all regulatory requirements. Stay within compliance. Keep track of cyclical updates such as 5-year PHA updates and 3-year compliance audits. To record any incidents or changes and update any affected documentations. And lastly is to watch out for any potential deficiencies in documentations and make sure that you pick them up before the inspectors do. Thank you very much for listening. For any questions regarding the webinar, please feel free to contact me at joyce.shen@rmpcorp.com. For any questions regarding the services RMP provides, please feel free to either contact me or call our general line at 949-282-0123 or refer to our website at www.rmpcorp.com for more information. Our website includes descriptions of the services we provide, as well as links to previously done webinars and informational handouts which we refer to as Tech Tips. Once again, thank you very much for listening and have a great rest of your day.